Welcome back to All This Math. This is Professor Parker. Please make sure you're subscribed to the channel. Make sure you like this video. Drop a comment down below if you got questions or comments about anything that we discuss in this particular video. And also share the channel with somebody else. All right. Now, what are we doing today? We're doing some work from the Reveal Math Curriculum, Grade 1, Lesson 4-8. So Unit 4, Lesson 8 from grade number 1 of the Reveal Math Curriculum. And I'm making this video specifically for my youngest son, Kwame, who's in the first grade, who's covering this type of content right now. But it's also for anybody else. Anybody else in first grade, this is for you. Any parents, grandparents, uncles, aunties, whoever, if you're trying to support a first grader, this is for you. Or maybe somebody that's in second grade, third grade that didn't fully understand this when they was in first grade or what have you. This is for everybody. All right. So this particular lesson deals with adding 3 numbers, right? Up to this point, we've only been adding 2 numbers, but now we're introducing a third number. So we're going to show how to add 3 numbers. The way I think about it is if you add in 3 numbers, it's really 2 problems in one, right? Let's look at these 3 right here. Let's start with these 3. We're going to get to these later, right? But let's start with these 3 up here. All right. So first I have 5 plus 4 plus 5. Those are my add-ins. We want to know what the sum is. Then I have 4 plus 5 plus 5. Those are my add-ins. We want to know what the sum is. Then I have 5 plus 5 plus 4. We want to know what the sum is. These should look familiar, right? You may notice that these are basically 3 different versions of the same expression, right? What is the difference between this first expression and the second one? Well, we could say that this 4 and this 5 switch places through the commutative property, which we talked about in lesson 4-7, the commutative property. That's when the orders switch around and it doesn't affect the final sum, right? And then this one right here, well, this last one, we could say that this 4 and this 5 switch places, right? So that means that we should end up with the same result. Now, how do we want to do this? Let's look at this first one. Let's deal with the number line. So let's start at 5 on this number line right here, right? So let's start at 5. Now we're adding, so we're moving to the right. And it's a 4, so we're moving 4 spaces. So we start at 5 and we count. We jump and we count. We go 1, then we go 2, then we go 3, then we go 4. And we stop at 9. That means 5 plus 4 is 9. So now we're at 9, but now it says plus 5. So that means we got to go 5 more spaces to the right. We're not subtracting, so we're not going left. We're adding, so we're going to the right. We got to go 5 more spaces. So from here, we're going to count 5 spaces. We're going to jump 1, jump 2, jump 3, jump 4, jump 5. Where we end up at? 14. So that means that the sum of 5 plus 4 plus 5 is 14. Then the same thing with 4 plus 5 plus 5. Now this we could do differently. We might not need the number line necessarily, or at least not at first, because 5 plus 5 is a double. And we've used the strategy of adding doubles, right? Or using doubles, right? To find sums. 5 plus 5 we know is 10, right? We probably have that memorized, right? Kwame, you should have that memorized. I think you do. But 5 plus 5 is 10 at any rate. So then this means that, so this is going to be 10. So now we have 4 plus 10. 4 plus 10. So let's think about it. If we started at 4, right? And we went 10 spaces to the right. Let's start at 4. Let's jump 10 spaces. Now I'm going to draw my jumps on the bottom of the number line. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where do I end up at? 14. So that's another way to get 14, because notice, these are the same 3 numbers, just in different order. They're the same 3 numbers in different order. And then last, we got 5 plus 5 plus 4. Now 5 and 5, that's a double, just like it was up here. So 5 and 5 is 10. Now we got 10 plus 4, right? So what if I go to this same number line up here with the 10, and then I'm adding, so I'm going to the right. Whenever you add, you move right on the number line. So I start at 10, and then I go 1, 2, 3, 4. I still end up with 14. No matter what, our sum is going to be 14 because we're dealing with the same 3 numbers. So that's another way to also represent or express the commutative property. How with the commutative property, when you change the order of the numbers, the sum is not going to be affected, right? The sum is going to be unaffected. All right. Now here goes some other examples down here. And it's a bunch of different, like I like to have fun with the math, right? I like to like use different strategies, get creative, try to figure out, okay, what makes the most sense. So with this first example, I got 3 plus 6 plus 3, right? What I might do is I might say, okay, well, what if I switch the 6 and the 3 into, what if I made it like this? 6 plus 3 plus 3. And if I do that, then what's going to happen with the 3 plus 3? 3 plus 3, that's a double. That's a double. So 3 plus 3 is 6. So now instead of doing 6 plus 3 plus 3, I'm really doing 6 plus 6. Since 3 plus 3 is equivalent, meaning it has the same value as, it's equivalent to 6. So let's do 6 plus 6. So if we start on the number line at 6, we jump once, twice, 3 times, 4 times, 5 times, 6 times. We end up at 12. Our final answer is 12. So that means that 3 plus 6 plus 3 is 12. Another way to do that is this. If I didn't switch the order of the numbers around, 3 plus 6 is 9. We can use the number line to prove that. If we start at 3, go 6 spaces to the right, we end up at 9. And then we pause at 9, and then we add 3 more, we end up at 12. So either way, we're going to end up at 12. That's why 3 plus 6 plus 3 is 12. So when you see 3 numbers, right? And to parents, adults, helping young people with this, don't let them get intimidated by the fact that there are 3 add-ins now instead of 2, because they're accustomed to seeing 2 add-ins. Just let them know it's basically just 2 problems in one. That's all it is. You do the first problem, right? That's one way to do it. Do the first problem, do 3 plus 6, right? If you're comfortable doing 3 plus 6, you get 3 plus 6. You know that's 9. Now you're going to take that 9. Now you got to add the 9 to the third number. That's your second problem. So you're doing 2 problems within one problem. It's 2 problems built into one problem, right? It's kind of like a double cheeseburger, right? Two patties, but it's one burger, but it's 2 patties, right? 2 and 1. So 2 for 1. All right. So now next example, 8 plus 2 plus 2. 2 plus 2 is a double. So I'm going to make that 4, right? That's the strategy I'm going to use. You don't have to do that. You could do 8 plus 2, get that sum, and then take that sum and then add it to 2 if you want to. You could do that. But I'm gonna use doubles. So 2 plus 2 is 4, and then I'm gonna do 8 plus 4. So I go here, and I go 1, 2, 3, 4. I stop at 12 because the sum is 12. All right, that's a coincidence because the first answer had a sum of 12. All right, now let's go to this next example. 5 plus 2 plus 7. So 5 plus 2 plus 7, there's no doubles. I can't use the double method. So I'm going to just add straight across from the left to the right. So I start at 5, right? And I go 2. I stop at 7. I pause at 7, right? And then I got to add 7 more. So from here, I'm going to go 7 more spaces. 1, 2, 3, 4, 5, 6, 7. I end up at 14. So the sum is 14. Then I'm down here, 1 plus 3 plus 8. 1 plus 3 plus 8. 1 plus 3. Let's say I start here. I start at 1, and I go 1, 2, 3. So 1 plus 3 is 4, right? And I got to take the 4 and add 8, because remember what I said. When you have 3 numbers, that's basically 2 addition problems within one problem. It's 2 addition problems built into one problem, right? So now I'm at 4, and then I'm going to add 8. So I'm going to go 8 spaces to the right. I'm running out of space here. 1, 2, 3, 4, 5, 6, 7, 8. And I end up at 12. Wherever you end up at is your sum. Wherever you end up at is your sum. Wherever you end up at on the number line, that is your sum. So we end up at 12. Now we got 2 more examples. Let's bang these out. 5 plus 7 plus 4. 5 plus 7 plus 4. So what I'm going to do is I'm going to go up here, start at 5. I'm going to go 7 spaces to the right. 1, 2, 3, 4, 5, 6, 7. I pause at 12 because I went 7 spaces to the right. So that gives me 12. You might want to do this on your paper. Just draw the little V, right? Draw a little V and then write the sum right there. That's 12. So now I got my second problem. My second problem is 12 plus 4. The sum of these 2 add-ins plus 4. 12 plus 4. So now from 12, I'm going 4 more spaces to the right. 1, 2, 3, 4. Oh, this is off the meter. So it's after 15. So what number is after 15? 16, right? My number line didn't have enough digits, but I know that one number after 15 is 16. I just use a little bit of reasoning, right? Now, last but not least, 9 plus 4 plus 4. So 9 plus 4 plus 4, right? Now, 4 plus 4 is a double. So I'm going to use that double strategy. So 4 plus 4 is 8, and I'm doing 9 plus 8. Now, that's going to go off the meter, right? That's going to go off my number line, I should say. But normally what I would do is start at 9 and then go 8 spaces to the right. And it's after 15 because I know that 9 plus 6 is 15 because I have my addition facts memorized. And again, to the parents that might be getting a little frustrated, thinking like, well, why they got to do it like this? Why can't they just memorize the facts? Well, eventually they will memorize the facts. But in the meantime, these methods help them to get a better understanding of numbers and to develop their number sense. This is how they develop their number sense, by understanding the number line. Because when they get to algebra and pre-algebra, they definitely going to need to understand the number line, right? When they get to algebra, they got to start, solving inequalities, graphing linear functions and all that. They're going to have to really have a strong foundation of the number line. So why not get it early in the first grade? Why not get it now? So this is why, right? Because I understand, like you wonder, like, well, why they got to learn this? Well, because it's going to prepare them for this, and this, right? And on a lot of the other videos on my channel, I talk about that. I talk about like the purpose of the math. Like, why is this method being used? How is this method helpful? Because down the line, they're going to encounter some other types of problems. And if they have a strong foundation in this particular topic, then they're going to be ready for that next topic. All right. So anyway, 9 plus 8 is 17, right? Because 9 plus 6 is 15. So 2 more after 6, 2 more in addition to 6 would be 8. So you would go 16 and then 17. All right. But this is lesson 4-8, grade 1 from the Eureka curriculum. And I just want us to understand, adding three numbers. But this is something that's got to be practiced, right? Practice this as much as possible. So just parents, give your children random opportunities to add three numbers. Just make up numbers, right? Within 20, right? Because we're dealing with numbers within 20 right now, right? So have them add three numbers, right? Just make up your own examples. Have them do that on a regular basis, because mathematics is like sports. You got to get your repetition and you got to get your practice in. All right. So like I said, make sure you subscribe to the channel. Make sure you drop a comment down below. Make sure you share this video with somebody and like the video too. Make sure you like the video. All right. Don't be a hater. All right. But share the video with somebody that you feel could benefit from it. And I'll see you on the next video. Peace.